Scientists were completely left speechless. For the first time in history, a spacecraft sent back images of Jupiter so detailed, so strange, and so unexpected that researchers at NASA sat in silence, staring at their screens, unable to explain what they were looking at. Some of them simply stopped talking entirely. Others reached quickly for their phones to call colleagues who were not even on shift that day, just so someone else could confirm they were truly seeing the same thing. This single image changed everything we thought we understood about the largest planet in our solar system. Storms that should not exist. Colors that defy every known model. Structures buried deep inside the clouds that scientists had predicted for decades but never actually seen until now. What you are about to witness is not science fiction. It is real data, captured by real cameras, orbiting a real planet nearly 400 million miles away. And by the end of this video, you will understand why even the most experienced planetary scientists on Earth are calling this the most important discovery of their careers, and why some of them admit it has completely shaken their confidence in what they thought they knew. Take a second and really picture it. A room full of people who have devoted decades of their lives to studying this exact planet, people with doctorates, people who have published hundreds of research papers, and for a moment, none of them could say a single word. That silence, more than anything, tells you exactly how significant this moment truly was for the entire field of planetary science, and it is exactly why we need to break down what actually happened, piece by piece, discovery by discovery. Before we go further, make sure you are subscribed, because this channel breaks down the biggest space discoveries before anyone else does, and we do it in a way that actually makes sense. And stay until the end, because the final discovery in this video completely changed what scientists believed about Jupiter, and honestly, about our entire solar system. It is the kind of revelation that makes you question everything you learned in school, the kind of moment that gets textbooks rewritten. Trust me, you do not want to miss where this story ends up, because it ties everything together in a way I promise you will not see coming. To understand why these new images matter so much, we need to go back to the beginning of the mission that captured them. This spacecraft launched years ago, carrying instruments specifically designed to survive Jupiter's brutal radiation environment, the harshest of any planet in our solar system. Its primary purpose was simple to state, but incredibly difficult to achieve. Fly closer to Jupiter than any spacecraft before it, and capture data no telescope on Earth could ever hope to gather, no matter how powerful. The journey itself was extraordinarily long and difficult from the very start. Engineers had to design shielding thick enough to protect delicate electronics from radiation levels that would fry a normal satellite within minutes of exposure. The spacecraft had to perform precise gravitational maneuvers, slingshotting around planets to build up enough speed for the multi-year journey across empty space. Every course correction had to be perfect, because a single mistake, even a tiny miscalculation, could have ended the mission before it even began, wasting years of effort and billions of dollars. When the spacecraft finally arrived and began its close approach, Mission Control held its breath. Nobody knew exactly what they would find, and honestly, nobody expected it to be this dramatic. Years of planning, thousands of engineering hours, and an enormous amount of public funding all led up to this single moment, the moment the first signals finally reached antennas back on Earth. Everyone in that control room understood that whatever came through those screens would either confirm everything they believed or challenge all of it at once. Some team members had been working on this project since before some of the younger engineers on staff had even finished high school, which gives you a real sense of just how long this moment had been building toward, quietly, patiently, one test and one simulation at a time. The first major reveal came almost immediately, and it stunned everyone watching. Cameras captured swirling storm systems near Jupiter's poles, unlike anything ever documented before in the history of planetary science. Instead of one massive storm, like the famous Great Red Spot near the equator, scientists discovered clusters of enormous cyclones arranged in strange geometric patterns, spinning in perfect formation around both poles simultaneously. To put this in perspective, imagine standing on Earth and looking up to see not one hurricane, but 8 or 9 enormous hurricanes, each one wider than our entire planet, locked together in a mesmerizing dance that never seems to break apart, never drifting, never colliding. Nothing like this exists anywhere else in our solar system. Not on Saturn, not on Neptune, not even on distant Uranus, nowhere at all. Researchers had modeled turbulent weather patterns before using powerful supercomputers, but nothing prepared them for this level of organized chaos. Why would storms this massive maintain such a stable, symmetrical arrangement for years without collapsing into each other or drifting apart? That question alone kept scientists debating for months across multiple research papers. And just when the team thought they finally understood the pattern, the data revealed something even stranger lurking beneath the clouds, something that would completely change the conversation. Some researchers even went back and re-examined old data from previous missions, wondering how something this obvious could have been missed for so long. The honest answer was simple. Earlier instruments simply were not sensitive enough to catch it, and the resolution needed to reveal this kind of structure only became possible with this generation of cameras. It is a humbling reminder that our previous picture of Jupiter, the one printed in textbooks for decades, was never wrong on purpose. It was just incomplete, waiting for better tools to fill in the missing pieces. The second discovery pushed the boundaries of what scientists thought was even possible. Using specialized instruments that could peer beneath Jupiter's thick cloud tops, researchers detected massive plumes of water and ammonia rising from deep within the planet, far more violently and far deeper than any existing model had ever predicted. This was unexpected because scientists had long assumed Jupiter's atmosphere behaved in relatively uniform, predictable layers, much like a calm, layered cake sitting quietly in the sky. Instead, the data showed turbulent mixing extending hundreds of miles down into the planet, essentially rewriting textbook diagrams that had stood unchallenged for decades of prior research. This discovery mattered enormously because Jupiter is often used as a reference model for understanding gas giant planets throughout the entire universe, including thousands of exoplanets discovered orbiting distant stars light years away. If our foundational assumptions about Jupiter's interior were wrong, then everything scientists inferred about similar planets elsewhere in the galaxy needed to be reconsidered as well, from their weather patterns to their potential habitability. Suddenly, a discovery about one planet in our own backyard had implications stretching across the entire field of planetary science, touching research happening at universities all over the world. Graduate students who had spent years building models based on the old assumptions now faced the strange reality of having to revise their own dissertations. It is rare for a single data set to ripple outward that far, that fast, into so many unrelated corners of science. Even researchers studying planets outside our solar system, worlds we can barely photograph as anything more than a single pixel of light, suddenly had new reason to question the assumptions baked into their own calculations, forcing a wave of quiet reanalysis across observatories that had nothing directly to do with this particular Jupiter mission at all. Let's take a moment to really look at what these instruments captured, because the images themselves tell a story that words cannot fully convey. The rare photographs released by the mission team show swirling blues, golds, and deep reds mixing together in patterns that almost look painted by hand, rather than produced naturally by chemistry and physics. The specialized camera responsible for these images used multiple filters to capture wavelengths completely invisible to the human eye, then combined them into false color composites that reveal structures otherwise entirely hidden from view. When these images were first released publicly, the reaction was immediate and overwhelming. Social media exploded with people sharing the photos, absolutely amazed that something this beautiful and this complex existed just a few 100 million miles from Earth, close enough to feel almost like a neighbor. But the public reaction was nothing compared to the reaction happening inside NASA's own control room that day. Veteran scientists, people who had spent entire careers studying gas giants and writing papers about them, described being brought to tears by the clarity and detail of what they were seeing for the very first time in their working lives. That kind of raw emotional reaction from seasoned professionals tells you just how significant this moment truly was, and it is exactly why this footage spread so quickly around the world. News outlets that rarely cover space stories suddenly dedicated entire segments to these images. Often even people with no background in astronomy found themselves staring at their screens, completely captivated by colors and shapes they had never imagined a planet could produce. Art teachers used the images in classrooms to talk about color theory, and photographers debated online about the exact processing techniques used to bring out such vivid, almost unreal detail from raw sensor data. Now we arrive at the strongest part of this story, the mystery that has scientists genuinely confused and, in some cases, a little unsettled. Deep within Jupiter's magnetic field, instruments detected energy signatures that simply should not exist according to current physics models built over the last several decades. Let's introduce this properly. Jupiter possesses the most powerful magnetic field of any planet in our solar system, generated by swirling metallic hydrogen deep beneath its clouds, a substance that barely exists anywhere else. Scientists expected this field to behave in predictable, well-understood ways based on decades of prior observation from both spacecraft and ground-based telescopes. Instead, the new data revealed sudden, unexplained bursts of energy rippling through the magnetosphere, bursts that do not match any known process currently described in planetary physics textbooks. Here is why this is so impossible. These energy bursts appeared in regions where the magnetic field should have been stable, calm, and completely uneventful, based on every previous model. There was no obvious trigger, no solar storm, no known external event that could explain the sudden spikes in energy. Scientists ran the data through multiple independent models, expecting to find an error somewhere in the calculations. They did not find one. The readings were consistent, repeatable and undeniably real, appearing again and again across separate observation windows. Teams of physicists, some of the most respected researchers in the entire field, publicly admitted they had no clear explanation for what they were seeing. Some proposed exotic theories involving previously undetected interactions between Jupiter's moons and its magnetic field, interactions nobody had considered possible before. Others suggested entirely new physical processes might be occurring deep inside the planet that current science has not yet identified or even properly imagined. When you have world-class experts openly admitting they are confused, standing in front of cameras and saying, "We simply do not know," you know you're witnessing something genuinely extraordinary. This single mystery alone could reshape our understanding of planetary magnetism for the next generation of scientists and possibly influence how future missions are designed from the ground up. Some engineers have already begun discussing whether upcoming spacecraft need entirely new instruments sensitive enough to catch these bursts in real time, rather than discovering them after the fact, buried inside months of raw data. Yes, nobody wants to miss the next one, especially after realizing just how much valuable information may have already slipped past earlier missions simply because nobody was looking closely enough or fast enough at the right moment. There is even a growing sense among some researchers that this mystery might connect to something even larger, perhaps related to processes occurring deep in Jupiter's core that influence the entire magnetosphere in ways nobody has mapped out yet. Until more data comes in, it remains an open question, and honestly, that is part of what makes it so exciting to watch unfold in real time. Beyond the headline mysteries, this mission produced a rapid series of smaller but equally fascinating discoveries, each one arriving in quick succession over just a few weeks of analysis. Discovery 1. Researchers identified previously unknown lightning storms occurring in regions of Jupiter's atmosphere once thought far too cold and far too stable to support any kind of electrical activity, forcing scientists to rethink how atmospheric chemistry actually works on gas giants across the galaxy. Discovery 2. New thermal imaging revealed hotspots scattered unpredictably across Jupiter's surface, areas releasing far more internal heat than current models could reasonably explain, strongly hinting at processes happening deep within the planet's core that remain completely mysterious to this day. Discovery 3. Instruments detected surprising chemical signatures in Jupiter's upper atmosphere, including trace compounds that some researchers believe may form through processes never previously observed on any gas giant anywhere, opening entirely new questions about atmospheric chemistry that nobody had thought to ask before. Discovery 4. Precise measurements of Jupiter's rotation revealed tiny but scientifically significant variations, subtle wobbles that suggest the planet's interior structure may be far more complex and layered than the simple models scientists have relied on for decades of textbooks and lectures. Each of these discoveries on its own would have been considered a major finding, worthy of its own dedicated research mission and years of follow-up study. Together, arriving all at once within a single data set, they paint a picture of a planet scientists thought they understood completely, but actually barely knew at all. Conferences that were originally scheduled to discuss routine mission updates suddenly turned into marathon debate sessions, with researchers staying long after hours trying to reconcile 4 separate anomalies that, on their own, were already hard enough to explain individually. Some scientists have jokingly started calling this the busiest data release of their careers, joking that they came into the conference expecting a quiet status update and left with enough unanswered questions to fill the next 5 years of funding proposals. Step back for a moment, because this story is no longer just about Jupiter anymore. These discoveries carry implications reaching far beyond a single planet floating in our solar system. For our solar system as a whole, this data forces scientists to reconsider how gas giants formed billions of years ago, and how their internal processes have shaped the orbits and compositions of everything around them, including the asteroid belt, countless smaller moons, and possibly even the formation of Earth itself. For our broader understanding of the universe, Jupiter serves as the nearest and most detailed example we have of a category of planet that appears to be incredibly common throughout the entire galaxy. Thousands of gas giants have already been discovered orbiting distant stars, and until now, scientists used simplified Jupiter-based models to estimate their behavior, atmospheres, and internal structures with reasonable confidence. If those models were fundamentally incomplete all along, then our understanding of countless worlds scattered across the galaxy needs to be seriously revisited, possibly changing decades of published research. And for humanity as a whole, this mission represents something deeper than just data and images. It shows what becomes possible when we commit years of effort, immense financial resources, and brilliant engineering toward a single ambitious goal, simply to answer questions about a planet we can already see glowing quietly in our own night sky. It is proof that curiosity, when funded properly and pursued patiently, still has the power to rewrite what an entire species believes about its own cosmic neighborhood. Think about how many different careers, engineers, physicists, chemists, mathematicians, computer scientists, all had to work together seamlessly for years, just so a handful of cameras could send back a picture worth staring at for hours. None of them will ever meet most of the people who will eventually see their work online, and yet their effort now sits in classrooms, phones, and living rooms all over the planet, sparking curiosity in people who may grow up to continue exactly this kind of research. Here's something worth sitting with for a moment, because it changes how you might think about everything else we assume we understand. Jupiter is not some distant, unreachable object hidden at the far edge of the universe. It is the largest planet in our own solar system, studied by telescopes for centuries, visited by spacecraft multiple times before this particular mission ever launched into space. And yet, despite all of that history and all of that prior research, we were still fundamentally wrong about how it actually works underneath the clouds. If we could be this wrong about a planet we have been watching for hundreds of years, a planet practically sitting in our cosmic backyard, what else have we misunderstood without even realizing it? What assumptions are we currently making about other planets, other moons, even our own Earth, that future discoveries might completely overturn in the years ahead? Science is not a finished book filled with settled, permanent answers. It is an ongoing, humbling process of discovering just how much we still do not know, no matter how confident we felt yesterday. And Jupiter just reminded an entire generation of scientists of exactly that lesson in the most dramatic way possible. Maybe that is the real takeaway here. Not the storms, not the magnetic anomalies, not even the plumes rising from deep within the clouds, but the simple, humbling reminder that certainty is often just the story we tell ourselves before better data arrives. It is worth remembering the next time anyone tells you a question and science is fully settled, because history keeps showing us that settled is often just another word for not yet tested closely enough. The mission responsible for these images is still active right now, continuing to orbit Jupiter and gather new data with every single pass it makes around the planet. Scientists expect even more discoveries in the coming months and years, as the spacecraft continues probing deeper into the mysteries hidden beneath those swirling, endless clouds. What we have seen so far may only be the beginning of a far larger story still waiting to unfold, one chapter at a time, one flyby at a time. Somewhere out there, 400 million miles from where you are sitting right now, a spacecraft engineered by human hands is quietly rewriting everything we thought we knew about one of the most magnificent planets in existence. And that, more than anything else, is a reminder of just how much wonder is still left for us to discover if we are only willing to keep looking, keep asking questions, and keep sending our machines out into the dark to check. Every new pass around Jupiter is another chance for the unexpected to show up on a screen somewhere on Earth, another chance for a room full of scientists to fall silent all over again. If this video blew your mind, smash that like button right now, because it genuinely helps this channel grow and reach more people who love space as much as you do. Subscribe if you have not already, so you never miss the next major space discovery breakdown the moment it drops. Drop a comment telling me which discovery in this video surprised you the most. I read every single one. And if you want to see what other hidden secrets our solar system might be hiding, click on the next video appearing right on your screen, because trust me, it is just as unbelievable as this one, maybe even more. Thank you so much for watching all the way through today, and I will see you in the very next video, where we dig into another mystery that science is only just beginning to understand.